Okay, welcome back, and now let's do an example, and we're going to show that the limit of absolute value of x over x as x approaches 0 does not exist. Now, we've seen this one before. There's a jump in the graph at 0 where it goes from -1 to 1. Okay, so there's a hole in the graph. Okay, so how would we do this? Well, let's show proof. Okay, so in this case here, we start with wanting to show that this is going to hold for any limit that we choose. Okay, so let's suppose that L is a candidate. So suppose L is a candidate for the limit. Right, so we just want to show this, that for any L that we might choose. Let's choose epsilon to equal 1/2. Okay? Okay, also let delta be positive. Okay, now, either, L is going to be greater than or equal to 0, or it's going to be less than 0. So either it's going to be negative or non-negative, right? So either L is less than 0 or L is greater than or equal to 0. Okay, so now what we're going to do is we're going to take each of these separately, see what we get. Now what we're going to do is, if that's the case, let's say if L is greater than or equal to 0, let delta equal, now here's where we're going to define delta. We're going to do, x. We're going to define x as delta negative. Delta over 2. So remember, we're choosing an x, right? So we're defining x in terms of delta. Thus, what do we get? Or hence, we get the absolute value of x minus 0, right? Because a is 0. Equals the absolute value of negative delta over 2 minus 0, which equals the absolute value of negative delta over 2, which equals delta over 2, which is less than delta. And now, now, what do we do? Well, the function, right? So here's absolute value of x over x minus L equals the absolute value of, now we're going to put in what x is, the absolute value of negative delta over 2 divided by negative delta over 2, minus L, which then this becomes positive delta over 2, and this becomes negative delta. This is just negative delta over 2. So this is going to become the absolute value of negative 1 minus L, which then we can factor out a negative 1. So then it'll become the absolute value of negative 1. So we get the absolute value of negative 1 times 1 plus L, right? Which is just going to be well, the absolute value of negative 1 is 1, and since L is positive or non-negative in this case, we can drop the absolute values. So this is going to just be 1 plus L, which is greater than 1. Why? Because L is positive or non-negative. Or okay, so this would be greater than or equal to 1, which is greater than epsilon, which we chose to be 1/2. Okay, so it violates there, so it didn't work. But now let's consider if L is negative, okay? So again, I'm continuing with the proof. Okay, I'm just erasing my part, but continue with the proof. So now, if L is less than 0, let X equal positive delta over 2, and then hence the absolute value of X minus 0 equals the absolute value of delta over 2 minus 0, which equals the absolute value of delta over 2 which obviously is equal to delta over 2, which is less than delta. Okay. And, right, so that meets that part. So, and now we go back to this. So it'd be f of x minus L equals the absolute value of x over x minus L. And again, we substitute in for this case x as delta over 2. So the absolute value of delta over 2 over delta over 2 minus L. Now in this case here, this is positive or positive, so this is going to be equal to the absolute value of 1 minus L. Now, since L is negative, we're taking the subtraction of a negative number. So to show that mathematically, we're going to actually write this as 1 plus the absolute value of L, because this is actually turning into a summation, okay? Because it's becoming a plus negative, but this is already negative, so the negatives cancel each other out, so it ends up being 1 plus L. But to show that L is positive, we put the absolute value signs around it. Okay, now, and again, 1 plus the absolute value of L is going to be greater than or equal to 1, which is greater than epsilon, which is equal to 1/2. And so it fails there as well. And so, therefore, the limit as x approaches 0 of the function absolute value of x over x does not exist. we're done. Have a great day.